Hello guys, how are you doing today? So today I'll be explaining the chapter 5 stoichiometry. I'm gonna do it until page 3 because at page 4 there is problem solving. I prefer you do this by yourself or with your teacher because in general it's better to practice by yourself. So chapter 5 stoichiometry. First thing is statement 1. They say at RTP, room temperature, it's 25 degrees Celsius, 1 atmosphere. Then we say that 1 mole of a gas occupies 24 decimeter cubed volume. However, at STP it is 0 degrees Celsius and 1 atmospheric pressure. Then we say that 1 mole of a gas occupies 22.4 decimeter cubed of volume. And now we are gonna apply some stoichiometric exercises. So in CQD number 1 grid, they told us when 4 moles of Fe react with excess chlorine, what mass of FeCl3 will be produced? So first thing, we need to understand what's happening. They told us that Fe will react with chlorine, which is usually found as CO2, to produce FeCl3, but we need to balance it. To balance it, you should already know how to balance it. You put a 2 here, a 3 here, and a 2 over here. So now it is balanced. They told us it's reacting with excess chlorine, so chlorine is out of the question. We are not considering chlorine right now. They told us 4 moles of Fe. Okay, we have originally 2 moles of Fe, but then it became 4 moles of Fe. How does the 2 become a 4? Very simply by multiplying it by 2. So then that means FeCl3 will go from 2 moles. So we multiply it by 2, then it will go from 2 moles to 4 moles of FeCl3. But now, are they asking us for the number of moles of FeCl3 or are they asking us for the mass that will be produced? They are asking us for the mass that will be produced. So, very simply, take your calculator and we're going to do 4 multiplied by the molar mass of FeCl3. Fe, is 56. Okay, in addition to 3 times the mass of Cl, which is 35.5. So doing it, it's going to be 56 plus 3 times 35.5. We are then going to get 162.5 grams. So then for part A, we got 162.5 grams of FeCl3 produced. Now, they told us what is the volume of chlorine at STP. Okay, so now they're asking about chlorine, so we're bringing it back into the equation. Okay, they're asking us what volume of chlorine reacts at STP. STP we said is 22.4. With 4 moles of Fe, we said the original equation is 2Fe plus 3Cl2 gives us 2FeCl3. So if 2Fe became 4Fe, then 3Cl2 will become 6Cl2. Okay, so we are going to multiply it by 2. So now, to find the volume of chlorine, we're going to take the number of moles, which is 6, and we multiply it by STP, which is 22.4. So 6 times 22. Oh, by the way, I forgot to do something important over here. I got 162.5, but then I forgot to multiply it by 4. So please do not forget to multiply it by 4. Okay, so here in part A, it's going to be 4 times 162.5, which will give you 650 grams. So please pay attention to this mistake. Don't rush like me. I'm just rushing because I'm a bit late right now. Anyways, so we're going to come back to part 2. We have 6 times 22.4. This will be then the volume of chlorine at STP. So 6 times 22.4. It is gonna be 134.4. So I'm gonna repeat for CQD1 what we did. First thing, we have to find the balanced equation. Okay, we found the balanced equation. After that, we need to measure. So if this one was 2 moles, then it became 4 moles. That means each and every one will be multiplied by 2. Or for example, it can happen like this. If it was 2 moles, and then it became 1 mole. That means if you have plus 3 moles, you will divide it by 2, so it will become 1.5 moles. So they are all ratios. Okay, and then for part B, we did the same thing, and then we multiplied the number of moles by STP and etc. Moving on to CQD number 3, we have hydrogen gas H2. Okay, let us write the balanced equation. Will react with carbon monoxide CO to produce methanol, which is CH3OH. Okay, and they already balanced it for us. And yeah, it's balanced. Now they are telling us when 0.5 tons of H2 gas, so 0.5 tons of H2 gas, whenever you are given in mass, we need to convert it into number of moles. So how do we convert it into number of moles? If you remember the triangle, which goes like this, it is that the mass and then number of moles and molar mass. So to find number of moles, we need to divide the mass by the molar mass. So the mass, which is 0.5 tons, if we take it into grams, okay, always remember when you are dealing with tons or kilograms, the basic unit of mass in chemistry is grams. So to change from tons into grams, we need to multiply by 10 to the power of 6. So this is 0.5 times 10 to the power of 6 grams, okay, of H2. Now what is the molar mass of H2? It is 1 for a single H, but H2 will become 2. So we take 0.5 times 10 to the power of 6, which is 500,000 grams, and we divide it by 2. Okay, so that means the number of moles, or the new number of moles, let me make it in blue, of 2H2 is 250,000. Okay, they said it reacts completely with CO gas. That means if the 2H2 is fully used up, that means the CO is also fully used up. So there is no excess and no limiting reagent. They told us that the amount of methanol produced was 3 tons. So let us also find the number of moles of methanol. Calculating, first of all, the molar mass of methanol, it is gonna be 12 plus 3 plus 16 plus 1, which gives us 32. So the molar mass of ethanol is 32 grams. Now again, to find the number of moles of ethanol, we are gonna apply the mass divided by molar mass rule. So the mass, which is 3 tons, or in grams, it's 3 times 10 to the power of 6, divided by 32 grams. Alright, so now we are gonna get that the number of moles of CH3OH is 93,750. Now here is where it becomes interesting. Okay, notice how we can get two possible number of moles. We can get the number of moles based on the H2, okay, which is the total yield, okay. So if you use all of H2 and all of CO, okay, what is the total yield? Whereas the given yield. So over here we found our given yield. Alright, definitely if you have a different way to do this, I would prefer you do it, but this is the way I do it. So you calculate and find your given yield. Now we calculate what was the potential yield, or the maximum yield. So we have our given yield. Let us calculate our maximum yield. If you remember how to calculate the maximum yield, it was very simply 2H2 will give us 250,000. What about 1 CH3OH, or in other terms, 2 moles became 250,000 moles. How much will 1 mole become? Very simply, by doing cross multiplication, it becomes 250,000 divided by 2, which gives us 125,000. Now we have our maximum yield. So we found our maximum yield and we have our given yield. very simply, we can now find the percentage yield. What is the percentage yield? It's very simply the given yield divided by the maximum yield multiplied by 100. Alright, so our given yield is 93,750 divided by the maximum yield, which is 125,000. We are then gonna get 3/4. But don't forget to multiply it by 100, and then you are gonna get, so times 100, and then you are gonna get 75%. So the percentage yield in this case is 75%. So of course, if you have an easier way to do it, please do it. I would prefer you do it. But my way of doing it, I'm gonna repeat it one more time. So they gave us the balanced equation. They gave us the mass of H2 that was used. Okay, so we can find the number of moles of H2 that was used. So calculating it, we did mass divided by molar mass, and then it became 0.5 times 10 to the power of 6 grams divided by the molar mass of H, which is 2 grams. Then we got it to be 250,000 moles. This was the number of moles. Then they also gave us the amount of methanol produced, which we found to be 3 tons. So again, mass divided by molar mass. 3 times 10 to the power of 6 grams. Don't forget to change it to grams. Divided by the molar mass, which is 32 grams. And we got it to be 93,750. Now, we said that there is the given yield, which is this over here. This is our given yield versus the maximum yield. How do we find the maximum yield? Very simply, to find the maximum yield, we are going to apply stoichiometry. So if 2 moles of H2 gave us 250,000 moles, how much will 1 mole of CH3OH give us? And then you do the stoichiometry, you are going to get 250,000 divided by 2, which will then lead us to 125,000. Now this is the maximum possible yield. And to find the percentage yield, it's very simply the given yield, which is 93,750, divided by the maximum yield, which is 125,000. Okay? And then all of it is multiplied by 100. Then if you do it on your calculator, you are going to get 75%. This is how I do it personally, because I find it logical. If you have another way that you find logical, of course, you can use it. Alright, so let us move on to CQD number 17. The metal zinc, Zn, reacts with acid to release hydrogen, H2. Let us write the equation. The equation is Zn reacts with an acid, we're going to say an acid, to release H2 gas. Now, which acid that we know releases H2 gas or has H2 in its components? Very simply, the acid is H2SO4. Okay? But then that leaves us with the Zn and the SO4. So they will form a compound. Zn and SO4 will form a compound by themselves. So ZnSO4. So Zn plus our acid, which is H2SO4, will give us H2 plus ZnSO4. They told us what volume of what volume of hydrogen gas would be produced at room temperature and pressure, RTP. That means 24 is the volume, so 24 decimeter cubed. So what volume of hydrogen gas would be produced at RTP? 3.27 grams of zinc. 3.27 grams of zinc react completely with excess sulfuric acid. So here, very simply, we need to find the number of moles of hydrogen gas. After that, we would be able to find the volume of hydrogen gas. So to find the the number of moles of hydrogen gas, we need to find the number of moles of zinc. So 1 mole of zinc will, usually it will give us 65 grams because this is the molar mass. But they told us instead 3.27 grams are used. So to find the number of moles of zinc, it's gonna be 3.27 divided by 65 grams, which is this big number, or 327 divided by 6,500. Now, it was 1 mole, and then it became 327 divided by 6,500 moles. Okay, so 1H2 is also gonna become 327 divided by 6,500. By now, it should be really easy to do stoichiometry. Okay, so how do we find the volume of H2? We very simply multiply this one by 24. So multiplying 327 divided by 6,500 by 24, we are gonna get approximately, rounding it, 1.2. If they asked to two significant figures, you round it to 1.2 decimeter cube. So for CQD number 17, the answer is 1.2 decimeter cube. So in statement number 4, they told us to find the empirical formula. Oh, no, they didn't tell us. They just told us find empirical formula, simplest formula of an organic compound given its percentage composition. Okay, so this is gonna be fun. A hydrocarbon means CH, so CXHX is 75% by mass carbon. Find its empirical or simplest formula. So this is our hydrocarbon. We do not know what it is, but they gave us a hint telling us that our hydrocarbon is 75% by mass carbon. So if we are going to make a formula, we have carbon plus hydrogen will give us the hydrocarbon. We are going to find its empirical formula. Okay? They told us 75% by mass is carbon. So 75 over 100 multiplied by the mass, which we will call X, is carbon. That leaves then 25% of the mass being hydrogen. And that will then leave us with 100 over 100, because 75 plus 25 is 100 over 100. That means the hydrocarbon is made up of 75% carbon, 25% hydrogen. Okay, but 100 over 100 of what? Of the total mass, which is X. Okay, so now to make it a bit easier, we are gonna say that the total mass is 100 grams. So it's in percentage and easier. That means 75 grams is carbon and 25 grams is hydrogen will give us 100 grams of the hydrocarbon. Now we divide by the molar mass. We know that so the 75 grams divided by the molar mass of carbon, which is 12, in addition to the 25 grams divided by the molar mass of the hydrogen, which is then 1 in this case. Okay, so 75 divided by 12 is 6.25. Okay, and then 25 divided by 1 is 25. All right, but we don't stop here then. Okay, so I cut off the part over there. We were left with 6.25 being for carbon and 25 being for hydrogen. Now this step is the most important step. We are gonna divide them, okay, all by the smallest number so that our carbon is 1. Okay, so that means 6.25 is the smallest number, so we are gonna divide it by itself, divided by 6.25 for carbon. And for hydrogen, we have 25 divided by 6.25. That means carbon is 1, okay, and hydrogen is 4. So C1H4, or in other terms, CH4. So for CQD number 20, that is our final answer. Now, to CQD number 19, the empirical formula of a compound is CH2O, and its molar mass is 60 grams per mole. Find the molecular formula of the compound. Very simply, we have the empirical formula, and the molar mass of a compound. So what we need to do is we need to add all of the masses to find the molar mass of the empirical formula. So it's gonna be CH2O, so 12 plus 2 plus 16, so then the molar mass is 30. Now what we do is we divide the molar mass of the compound, 60, divided by the molar mass of the empirical formula, which is 30. We're gonna get 2. So now very simply, that means we are gonna multiply the empirical formula by 2. So it is C2H4O2. And that's it for CQD number 19. Okay, so let us apply the same rule for exercise 10. And the empirical formula of a compound is this. So we need to find the molar mass. Very simply, to find the molar mass, we know that carbon is 12, so 12 times 2, plus hydrogen, which is 1 times 7, which is 7, plus the molar mass of nitrogen, which is 14. So we get 45. Then the molar mass of the compound is 135. So we divide 135 by 45 and we get 3. So now we multiply C2H7N by 3 and then it becomes C6H, 7 times 3 is 21, H21, and then N3, and that is the empirical formula. So now we have some top questions. We're gonna do them. Alright, so we move up to CQD 21. During a lab session, students were asked to prepare hydrated magnesium sulfate by adding an excess of dilute sulfuric acid to magnesium oxide. Each student was handed a different mass of magnesium oxide. At the end of the experiment, each student dried and weighed the crystals obtained. Which student produced the highest percentage yield of hydrated magnesium sulfate? So very simply, like we said before, it is they are asking for the percentage yield. So to find which one is the highest, we're gonna take of the produced, or in other terms, given, the ones that we are given or the ones that we produced, versus the mass of the maximum or original. You can do it with number of moles and you can do it with the mass. So in this case, it's 9.5 divided by 5, okay, as an example, and we are gonna get 1.9. Alright, so let me just write. So I will write the ratios over here. It's 1.9, then 24 divided by 10 is 2.4, then 35.8 divided by 16, it is 2.23, or 24 actually, so 2.24. Then D is 46.6 divided by 24, which gives us a ratio of 1.9. Then we have 56.7 divided by 36, which gives us 1.6. So definitely the biggest ratio is B. So the student that produced the highest percentage yield is B. So now moving on to question number 22. Ammonium sulfate is used as a fertilizer. It's produced from ammonia and sulfuric acid as shown in the chemical equation. So then we have 2NH3 plus H2SO4 will give us NH4 2SO4. So calculate the maximum mass of ammonium sulfate produced from 680 grams of ammonia, okay, NH3, using the following steps. They told us that the formula mass, aka the molar mass of ammonia, is 17. So very simply, we need to calculate the number of moles of NH3 in 680 grams. So that's 680 divided by 17, which gives us 40 moles or 40 N. So now we have to deduce the number of moles of NH4 2SO4. So if 2 became 40, how much will 1 become? 1 will then become 20 N. So part B is 20. Then calculate the molar mass of NH4 2SO4. So this is quite simple. We know that nitrogen is 14 added to 1 times 4, which is 4. But now look what happens. All of this is 18 in itself. We multiply it by 2. and we get 36. So we finished this part over here. Then we added 2 SO4. Sulfur by itself is 32, so plus 32 in addition to 16 times 4, which is 64. So 36 plus 32 plus 64 will give us an answer of 132. So the molar mass of NH42SO4 is 132 grams. Now we need to calculate the maximum mass of ammonium sulfate produced. Very simply, we are gonna multiply the number of moles of ammonium sulfate that we found in part B by the molar mass of ammonium sulfate. So 132 multiplied by 20, we are gonna get 2,640 grams, and that is it for CQD number 22. And finally, last but not least, we have CQD 23. So CQD number 23, the relative atomic mass of an atom is given by comparing the mass of that atom against a standard atom. This is just a statement in A. Now, part AI. What is the symbol of the standard atom? Include its mass number. Now here, this is something we haven't taken before. It is new, but it is important. What you should know is that the standard atom is carbon 12, denoted like this, C12. Okay, ammonia has a relative molecular mass or molar mass of 17, and lithium chloride has a relative formula mass or molecular mass or molar mass of 26. A student claims that the term relative molecular mass can be used for both compounds. I just corrected my own mistake by reading that sentence, okay? You cannot say that a student claims that the term relative molecular mass can be used for both compounds, ammonia and lithium fluoride. Do you agree with him? Well, based on the answer key, they say no, we cannot agree with him, because relative molecular mass is for molecules or covalent compounds like ammonia, whereas the relative formula mass is used for ionic compounds. So ammonia is a covalent bonded compound, whereas lithium chloride, which is LiF, is an ionic compound. So definitely you cannot use the same term for both of them. So for NH3 or covalent compound, we use relative molecular mass, or for lithium fluoride, which is an ionic compound, we use relative formula mass. Now part B, a 0.174 gram of gas X has a volume of 72 centimeter cubed at room temperature and pressure. So how many moles of gas X in 72 centimeter cubed, given that the volume is 24 decimeter cubed? That means we need to change centimeter cubed to decimeter cubed. Very simply, we multiply by 10 to the power of minus 3. Okay, divided by 24. So the given volume divided by the original volume. And we are gonna get 3 times 10 to the power of negative 3. Now, what is the relative molecular mass? Given this statement, we can say that it's a covalent compound. However, to find the relative molecular mass, or in other terms, the molar mass, we are given the mass, which is 0.174. Then we can divide it by the number of moles, which is 3 times 10 to the power of negative 3. So 0.174 divided by 3 times 10 to the power of negative 3, it is 58 grams per mole. So that is the molar mass in part 2. Part 3, it is found that gas X is a hydrocarbon of empirical formula C2H5. Okay, so very simply what we need to do is we need to find the molecular or the molar mass of this C2H5. So very simply it's 12 times 2 plus 5, so 29. And then we take the given molar mass, which is 58, divided by the molar mass of C2H5, which is 29, which will then give us 2. So that means the chemical formula of gas X is very simply C2H5 multiplied by 2, which will give us C4H10. Alright, so now we move on to part C. 12 grams of an oxide of iron is produced from burning 8.4 grams of iron. They need us to calculate the empirical formula of this oxide of iron. So an oxide of iron is made out of Fe and O, oxygen. Okay, so we know the mass of iron that is burned, it is 8.4. That leaves us with the mass of oxygen being burned, which is the total mass, 12 minus 8.4, so 3.6. Now we divide them by their molar masses. So it's going to be 8.4 divided by 56 and then 3.6 divided by 16. We are going to get 0.15 and 0.225. Now we divide them both by the smallest number, which in this case is 0.15, 0.15. And we are going to be left with 1 and 1.5. But we cannot leave it like this because they are telling us a molecule is 1.5, which doesn't make sense. So for it to make sense, we just need to multiply it by 2, so it becomes a whole number. So this becomes 2 and this becomes 3. So the empirical formula of this oxide is for Fe, it is 2, whereas for oxygen, it is 3, so Fe2O3. Now finally, last but not least, part D, another oxide of iron has the empirical formula of Fe3O4. One molecule of this oxide of iron contains 6 atoms of iron. Deduce the molecular formula of the oxide. So very simply, Fe3O4. They told us that the iron contains 6. So they multiplied it by 2. That means the oxygen you will also multiply it by 2. And you are going to get 8. And that is it for the 5.1, 5.2. The rest you can do them by yourselves as more practice. And thank you guys for watching and have a wonderful night.